In previous slide, actually one more thing I forgot to tell you, that viscosity, when you were talking about viscosity, actually there will be two type of viscosity: dynamic viscosity and kinematic viscosity. Okay. So, relationship is that mu equals rho nu. Okay. Dynamic viscosity mu and kinematic viscosity nu. Okay. And unit also, dynamic viscosity Cp, kinematic viscosity Cst. Here you can see the small capital thing again. So, small c, capital P. Okay, Poise, someone's name, scientist. St, Stoke. So, S capital. Okay, C S T. Okay, C small, S capital, T small. Okay. So, you should remember the units. Okay, you should not get confused when you are calculating something, and you should not put wrong unit also. Now you see the heat calorific value. Heat, you know already, certain heat is energy. Okay, and how to measure this one? You have to calculate the whole mass. You have to know specific heat capacity, temperature rise. Based on that, you can calculate heat. Okay. And what is the calorific value? Calorific value means how much calorie you are getting if you burn certain fuel. Okay. These days people are very much concerned about food and calorific value, right? Calorie, how much calorie you are gaining or burning. So, in our oil and gas also we will be using the term calorific value. So, calorific value means how much, if you burn certain fuel, how much energy it will be releasing. Okay. So, that we have to calculate. And latent heat, I think you may be knowing, if I have water, okay, let us say 30 degree centigrade. So, if start heating, what will happen, 100 degree centigrade it will reach, alright, then it will be steam. So, temperature when you are increasing from 30 degree to 100 degree centigrade, so this will be sensible heat. So, the one thermometer if you put there in water, so you can measure the temperature increasing 30, 40, 50, 60, 70, 80, 90, okay. But when it will be reaching at 30, it will be reaching at 100, so then temperature will not rise, rather it will be creating lots of steam, okay. It is taking heat, but it is not showing, okay. So, latent means sleeping or hidden, right. So, heat is hidden, that water molecule taking lots of heat and it is becoming steam. That water molecule means the molecular resonance and movement will be lower. When it is becoming steam, so molecule actually it is almost gaseous form, right. So, particle motion will be very high. So, there will be more energy in the steam particle, okay. So, more energy means it is taking from your heat whatever you are supplying. So, sensible heat, when you can measure the heat in using a thermometer, and latent heat means you cannot measure using a thermometer, okay, but it is taking heat, right. So, and unit also you should remember, heat unit is joule, right, joule, kilojoule. British thermal unit BTU also use, BTU, capital B, small t, small u. Many time I have seen capital BTU also, okay. But some books they are writing capital B, small t, small u. Sometime I have seen small BTU also, okay. So, you should not get confused. I think everything is all right. There may not be standard thing, okay. And temperature unit like degree centigrade already you know, Fahrenheit, Kelvin, and you have learned Rankine, okay. These are common. Kelvin normally we do not put degree symbol, right. This is SI unit says standard practice is that there is no degree symbol, but centigrade and Fahrenheit we put degree symbol. Degree, Rankine, R also we put degree symbol, okay. So, whenever you are learning you should learn the standard practice also. So, in Kelvin you should not put degree symbol, okay. Now, HCV, LCV I already explained actually in previous lecture, higher calorific value, lower calorific value. So, how to measure it and how to know it, okay. There will be bomb calorimeter, one term is called bomb calorimeter. Like this, you have one vessel, okay, closed vessel, insulated, okay, insulated vessel like this, okay. There will be lid and proper closure also, and inside there will be a fuel burning section. Okay. So, fuel will be burning inside. Let us say you take certain amount of methane, okay. Maybe for example, I am giving methane with air. Okay. Now, you will have one electric coil coming here, electric line. This will be gas or fuel inlet, okay, and this will be filled with water. Okay. Now, I will have one thermometer. So, how will they measure? Initially, you take certain amount of fuel, small amount, then you burn. How will you burn? You create one spark using electric line, like your bike and car will have spark plug, right? So, similar way you can create a small spark, very small amount of energy will be required, fuel will be burned, it will be getting heated up. So, that heat will be dissipated in water, okay. So, this water will be getting heated up. Let us say initial water temperature, for example, let us say T initial, say 30 degree, for example. I mean, actually how much they are taking, it will be their scientist job. And after burning, heat dissipated in the water, and it is insulated. This is insulated. Okay. Insulated means no heat will be going in or out. Okay. This vessel is insulated. So, whatever heat generated, so it will be heating water. Now, T final, maybe let us say 70 degree. Now, how much heat generated? Q equal M S T, right? M mass, how much water you have taken, and T means T final minus T initial, okay. How much mass of water, specific heat of water, then 70 minus 30. So, you got this much of heat generated, right. So, this much of total heat you got. So, it is actually higher calorific value. Now, it may have water molecule. Water molecule, if it is there inside this fuel, then fuel that water molecule will get heated up, it will take latent heat, okay. That is why I explained latent heat. It will take latent heat. So, latent heat means I think 540 gram per calorie per gram, I think, right. Latent heat, water latent heat, okay. Whatever I can remember, 540 calorie per gram, I feel, okay. So, we need to cross check. Now, the certain amount of water is there that will be evaporated, it will take latent heat. So, that heat actually you cannot use for your fruitful purpose, okay. So, your actual use of heat will be lower calorific value. So, LCV equals HCV, total heat whatever you got using your calculation Q equals MST minus latent heat taken by water molecule, okay. Fine. So, your customer, like say you are oil and gas surface production system engineer, and customer will be specifying, okay, we do not want to water more than this much of percentage, okay. If you have more than that, then they will not buy. You have to reduce again, you have to check your separator system, is there is fault in separator system, or you have to redesign, or you have to put a new separator with glycol and other units, and you have to remove the water content, okay. So, they will have BSW specification, BSW, basic sedimentation and water content, okay. If you have more than certain amount, then they will not buy, okay. So, you have to ensure that your oil or gas is having lower than that specified limit, okay. So, this calorimeter is called bomb calorimeter, okay. So, you are creating small bomb blasting, then your that heat will be increasing temperature of water. Now, measure water temperature, okay. It was initial, it was final, and this is total volume. So, finally, how much heat you got, you can calculate, fine. So, flash actually, so if flash is that, like how much amount of liquid or how much of gas is there in certain volume, okay. Gives amount of liquid phase or gaseous phase at any point in the process. At given temperature pressure, each component of hydrocarbon mixture will be in equilibrium, Okay. So, some amount of liquid will go into gas, gas will be coming into liquid. So, that will be creating one liquid equilibrium. Okay. So, if you are changing temperature pressure, then liquid equilibrium will be changing. So, that one term will come equilibrium factor or K factor. Okay. So, mole fraction of the component in the gas phase depends not only temperature pressure, but also partial pressure, how much pressure you are having a certain mole. So, that also will be controlling your equilibrium. So, equilibrium ratio, this is called equilibrium ratio, equilibrium K factor or K ratio sometimes they say, or K value, okay, K factor, K value, equilibrium ratio, and the formula is that Ki equals Yi divided by Xi. Okay. So, mole fraction of component I in the liquid phase is Xi, mole fraction of X, mole fraction of I component in the mixture. Okay. Composition of this one vapor phase, mole fraction of vapor phase of vapor okay, here spelling is like British American write VAPOR and I am writing VOPOR. So, if you are writing anything okay, but if you try to maintain uniformity, that is better. For example, if you are writing all in British style or all in American style, that is better. Okay. If you are mixing up is okay, but you should try to avoid mixing of British style or American style. Okay. So, K factor is defined as the distribution of the component between the liquid phase and gas phase. Okay. Because continuously gas will be going to liquid, liquid will be going to gas. So, one equilibrium will be maintained, but if you are changing pressure and temperature, that equilibrium will change, the ratio will change, pressure will change. Okay. So, when you are separating, actually you should know the equilibrium factor. Based on that, actually you can guess, okay, this much of liquid will be there in my gas. Okay. Heat capacity ratio. So, all our oil and gas calculations, actually we use this term K. Okay. This picture I have taken from Calorific book. If you see this, if your molecular weight is getting changed, then your K value is also changing. So, in our case, normally K value will be 1.2 to 1.3, okay, because we will have different long chain, short chain hydrocarbon. If short chain hydrocarbon is there, so K value will be different, long chain hydrocarbon is there, K value will be different, and number of molecular weight also will be depending on number of carbon atom is there in the molecule. Okay. So, normally it like 1.2 to 1.3. So, within this range our K value will be remaining. So, because this will be like 1920 this around. Okay. So, this will be our zone actually. So, whenever you are calculating for Boyle's law, Charles law, there will be one factor K. So, K the value you can take from there. So, air normally it will be 1.4, okay, but in natural gas we will have 1.28, 1.3, we take those values. If something is given, you can take directly that value. If not given, then you can sometime in exam I can ask guess a suitable value. When you are guessing suitable value, actually it should be within 1.2 to 1.3. If it is going out of this range, then we should not say this is suitable. So, whenever fluid you are getting from wellbore is there, wellhead is there, then choke will be there, then test separator will be there. Okay. So, test separator purpose is that you have to test wellbore or other composition you have to check wellbore life also. Okay. So, the test separator can be fixed type or maybe skid mounted or trawler mounted. So, a test separator is a vessel which is used to separate or measure small amount of oil and gas. You take and you measure what constituents are there in the oil or gas. Okay. Each well is periodically tested by diverting the flow from the production separator. Production separator means continuously it is producing, you are getting oil or gas. Okay. But test separator is that you are taking some time, monthly 2 times, 3 times, sometime monthly 1 time, and you are testing what are the composition is there. Whatever separator whole systems are there, if composition is changing, then maybe whole system may not work, or something will fail. So regularly you have to check, okay, this is my composition, this is my pressure rating, this is my all these things. If you once you get, then your production separator will be running smoothly. Okay. So keeping track of oil and gas from each well, evaluating reserve potential, diagnosing well problems. Okay. It is attractive to use test separator in each well, but if you have multiple well bore, then you can go through manifold and you can use one test separator. Okay. Many wells more convenient to pass through oil and gas from each well through the manifold and test it periodically. Frequently testing depends on the requirement. For example, most wells should have tested at least twice in a month. Okay. Most well we have tested twice in a month. Okay. 2 times in a month. Gas well normally one time in a month. Okay. So test separator can be vertical, horizontal, spherical, it can be 2 phase, 3 phase. So different types of separator will be possible. Okay. So equipment with different meters will be fixed on this one, separators. Pressure gauge will be there, potential test, periodic test, marginal well test. So different types of test will be conducted using your test separator. So this is not production separator actually. Okay. So you are taking a small amount of fluid and you are analyzing on the spot. Production separator, like if I differentiate between production separator, so test separator can be smaller, big, trolley mounted will be there, fixed type will be there. If I say production separator, it will have like diameter and length. Diameter will be like 12 inch to 15 feet. Okay. And most units will have 30 inch, means 2.5 feet to 10 feet. This is a common size. So you can guess how big it can be. 10 feet. Our height will be 5-6 feet, right? And it will be 10 feet. So more than our height. Length will be 6 to 70 feet. 70 feet, so high, right? Sometimes it will be very tall also. And common will be 10 to 40 feet. Okay. These are production separator ranges, size. Okay. Approximately you can guess, okay, this much of will be like this. So now we will go to separator. Okay. Separator, like 2 phase separator, if you see, like normally it will be horizontal. Okay. So normally you draw like this, 2 will be like curved to end, and inlet is here. Okay. Inlet means it is coming from wellhead to choke to here, and there will be one inlet diverter. It's called inlet diverter. Okay. And it will create 2 layers. This will liquid, because 2 phase we are saying, when we are saying, that means gas phase and liquid phase, liquid gas, and there will be mist extractor or mist eliminator. You see, I am drawing one valve. This one, you can remember, this is control valve, pressure control valve, right? So PC, pressure control, you can make like this. So gas out, and you have liquid one valve will be there, again control system will be there. So this will be like level controller will be there, LC. Okay. And this fluid, whatever you are getting, is oil out. Okay. Now you are creating 2 layers, and normally it will be 50% filled. So if you are making 50% filled circular cross section, so you are getting more area, surface area, interface area. Okay. If you are increasing 60% liquid filled, 40%, so your actually area is reducing. If you see from side view, this is largest area, right? And if you are making, say, more, this is liquid, you are making like this. So your total length is reduced now. The surface area is reduced, interface area is reduced. Okay. So interface area is required sometime, so that gas and liquid will be separating better way, okay, because more gas will be leaving the liquid surface, or gas liquid will be falling on the liquid surface, okay. So gas will be flowing through inlet diverter, okay, oil and gas mixture. So it will come like this, and gas will be moving up. When gas is moving up, all liquid particles should fall down. If there is small tiny particles are there, this mist extractor or mist eliminator extractor will prevent the prevent the small tiny liquid particle to going out through the gas line, okay. So we'll go to vertical separator. Okay, so vertical separator is like this. You will have vertical cylinder, okay, and you have to fix on bottom also, right, and like this, and your inlet will be like this. There will be again inlet diverter, okay, mist extractor will be there, and you are creating again two layers. Water is going out, control valve, water, or I can say liquid, and here also I can put gas word. This is liquid, this is interface area, and here I should put one control system, interface area, okay, inlet. Okay, so many times there will be one downcomer also. Okay, so downcomer, how does it work? It will be like this, and one pipe will be coming and one spreader will be there. Okay, liquid gas will be entering, liquid plus gas, okay, gas will be coming, and it will getting spread here, okay. When you are spreading, liquid gas will be separating properly, and again mist extractor gas layer you are getting, you are creating some layer liquid, and you are taking liquid out. So we will discuss later when we will go for three phase separation and emulsion separation. That time we will discuss further, but vertical separator is vertically tall, okay, and you will create layers again, two layers, one gas layer, one liquid layer, maybe three. If three phase is there, then you will have water, oil, gas layer, three layers, okay.